Hello students and welcome back to stretches and compressions. First thing I'm going to do is just reflect on what the rule was before we get into any big examples. And I think we used the letter K or something, but you know what? I'm going to use A and B's here. Okay, so let's say I put an A in front of the X and I put a B in front of the Y. Now those represent numbers, right? They could be fractions or they could be whole numbers. And what effect do they have? Well, first of all, the number that's crammed next to the X, we would be talking about a stretch in a horizontal kind of direction, taking a distance and stretching it a little bit further left and right. And that's talking relative to the y-axis. So what we're talking about would be something like this. You know, say your original function was this far away with this point. Maybe I'm going to compress it so it's half the distance. Okay? Maybe this point here was over that far away from the y-axis, and then I'm going to make that half the distance. So this would be maybe my new function, and this was my original function over here. Did something like that. So horizontal changes, okay, is whatever's in front of the x, but you take the reciprocal. Okay, so if this turns out to be a fraction, then it's going to be a compression. So let's see, compression, if you get a fraction. If a fraction, okay, and if you got something, if this guy here turns out to be a whole number, like for example, what if A itself was 1/3? This would be 1 divided by 1/3, which would work out to be 3. Well, that would be a stretch or an expansion. Okay, stretch if a whole number. And you know what? The same thing we've already seen happens over here with the number in front of y. The only difference is these ones here are horizontal and these ones over here are vertical. Okay, you're talking about vertical distances. So what I'm going to do now is let's get into some actual examples. We'll put some numbers in there and see what we can come up with. Okay, so here's my first example here. I'm going to write y equals 4 times the square root of 2x. Okay, so what I prefer to do is take this number in front of the function and divide it to the other side. Okay, so let's do that. Okay, so now I've got it into implicit form, and I'm going to look at what is the change on the x and the y, because I have some horizontal changes and I have some vertical changes. Let's do the horizontal changes here. The number in front of the x is a 2, which means that I'm going to get 1/2, the reciprocal. So that is compression. All of my horizontal distances are going to be half as big as they used to be. Then over here, for the number in front of the y's is a 1/4, so its reciprocal is 4, and that is a stretch. Okay, all the vertical distances are going to be 4 times as big as they used to be. Now, sometimes these become difficult to put on a grid, so I'm going to adapt the scale a little bit. I want to try to give you a bit of a picture of this thing, kind of show you what we're talking about. Used to be, we had the point 0, 0, and we had, let's see, what are we doing? We're going to be stretching. Okay, so, but that was half as big. Okay, sorry, just had to make the scale so it would be easier to graph. Okay, so we're going to make that 1, 2, 3, and 4. Used to be that when we went 1 to the right, we went up 1. But hold on, I got to make sure. Let's just make this 1 down here. Okay, I know the scales aren't the same here, but you'll see why in a moment. So we also used to have the point 4 was up 2. So this is what my original square root graph looked like. Okay, something like that. That was good old y equals the square root of x. So what's this guy going to look like? Well, first of all of these horizontal distances have been compressed by a half. So instead of going out to 4, we're going to go out to 2. Instead of going out to 1, we're going to go out to a half. Okay? In fact, you know what might be a really good idea is to take these 2 points and see where are they now. Okay, so this is the old location. Where are they now? Because otherwise it's really tough to do all these changes in your head. So the x's, I'm going half as far. So here I'm at 1, so now I want to be at 1/2. I used to be at 4, so now I'm at 2. Okay, and vertically I want to be 4 times as high. Okay, so I used to be at 1, so now I'm at 4. I used to be at 2, now I'm at 8. So these are my new points. I'm at 1/2, up 1, 2. Let's put a few lines here. So I used to be 1, 2, 3, 4, 6, 8. There we go. So at 1/2, I'm up at 4. And at 2, I'm up at 8. So I'm about roughly there. So there it is. There's my new transformed square root function. All right. Well, let's see how we're doing for time. Oh yeah, we've got time for the last example here, I think. Yeah, only got one more example. So let's clear the screen. And somebody says we have this function, y equals f of x. Okay? And they tell us that the zeros, which is another way of saying the x-intercepts, okay, are at -3 and at 2. Now, question, where are the zeros? Where are the zeros of the following function? Suppose we throw this at you now. F of 1/2 x. Okay? So that's what you got to do. You got to relocate where the zeros are. So here's a really good way to do it, I think. And this is going to be the method you're going to see me using with the rest of the chapter. I'm going to locate these old points. Now, zeros are just points that are on the x-axis. So these are the points we're talking about. Okay? And what we're really asking is, where are they now? Where are the new points? Let's just have a look at what changes we're making to x and y. Okay, so the y has nothing happening to it, so there's no changes at all. But the x has a 1/2 in front of it, which means I would like to multiply all my x distances and multiply them by 2. This point here at -3, that's -3 steps away from the y-axis, so its new location is now -6. Okay, I'm just doubling the distances. This point is 2 steps away from the y-axis, so it's now 4, 0. And there they are. That's my answer. Here and here. Those are the new zeros. And with that, I am going to stop for now.